All right, we're back again. Checking the records. Let's begin. No, I won't rap anymore. Don't worry about that. All right, so we got the definition and theorem 10.7 today to start, and we're dealing with inscribed angles. So here's what an inscribed angle is. An inscribed angle is an angle that is made up of two chords where they meet at a point on the circle. So if we look here, angle ABC is an inscribed angle. Notice how BC and AB are chords of the circle, and they're meeting at a point on the circle. That point is B. So this is an inscribed angle. All right. Now the thing with an inscribed angle is it's half the measure of the arc that it intercepts. Now you're asking, how do we know what arc it intercepts? Well, if you look at the name ABC, just pick the first and last letters of its name, and that tells you what arc it's going to intercept. Okay? So if we look at this, it's going to be this arc right here, arc AC. In fact, if you want, you can even make this look like a little bit of a Pac-Man eating a ghost. Okay? So angle ABC is inscribed, and angle ABC is going to be half the measure of arc AC. So if arc AC here is 70, then my angle here is going to be 35 degrees. It's going to be half. Now it takes us to theorem 10.8. What theorem 10.8 is saying is that if we have two angles that intercept the same arc, or if they intercept congruent arcs, then they're congruent. Well, if we take a look at angle D and angle C here, if we notice, they both intercept arc AB. So that's going to make angle D and angle C congruent to each other. And again, how can we check that to make sure? Well, angle D and angle C can go by a different name. Angle D is actually angle ADB in the picture, right? Angle C, if we look in the picture, is actually angle ACB. And hey, look at what the first and last letters of its name are, tell you that it's going to intercept arc AB. Next is theorem 10.9. Here's what theorem 10.9 is saying. It's really, really easy. That if I have a triangle inside of a circle and the hypotenuse is the diameter of that circle, then I'm going to make a right triangle with angle B being a right angle. So AC is the diameter here, and that's going to make B a right triangle, or right angle, excuse me, which makes then triangle ABC a right triangle. Angle B is a right angle, AC is the diameter, triangle ABC is a right triangle, AC is the hypotenuse of that right triangle. And then 10.10 is talking about an inscribed quadrilateral. So if I have a quadrilateral inscribed in a circle, the only way that can happen is if my opposite angles, in this case angle A and C, angle D and B, are supplementary to each other, okay? They're not equal. They can be equal, maybe, but they're not, because all the time though, they are going to be supplementary to each other. So angle A and angle C are supplementary, meaning they're going to add to be 180. Same thing with B and D. They're going to add to be 180. Next, we'll hit up some problems. Okay, we're back. We're going to do some of the problems out of the packet before I assign some. All right, so this is the measure of arc ST is what we're looking for here. So what I notice is I have an inscribed angle, 61 degrees, angle S. Remember, it is half the arc that it intercepts. So arc TU here then should be double that. That's 122 degrees. So that tells me then that arc ST, since we have a diameter here, this is 180 degrees, so arc ST is going to be 180 minus 122, and that gives me 58 degrees for arc ST. Number 5, we're looking for angle A. Angle A intercepts this arc here, BC, okay? Well, they gave me that arc AB is 54, and again, if I notice that AC is a diameter, so it's cutting a circle in half, so this circle then, this semicircle is 180. So if I go 180 minus 54, that gives me 126. So that tells me then that this arc BC is 126, which angle A here is what I'm looking for. It's inscribed with the 126. It should be half of that. So that's 63 for angle A. Next, there's a lot going on in this picture. You have to answer a lot of questions to deal with it. I'm going to do two of them. They're giving me arc LM is 84 degrees. They're also giving me that arc KN is 116. So the first thing I have to do is I have to find angle JKL. Well, if I'm looking here, angle JKL, I notice JL is a diameter. And remember, we had that theorem that said that if we have an angle inscribed in a semicircle right here, then that angle is going to be half of that semicircle. So that tells me 90 degrees for angle JKL. So this is actually a 90-degree angle right there. Right angle. Next we come down, we're looking for angle KMN. So here's angle KMN right here. So here's what I noticed, KMN. So I noticed that KN are the endpoints that I want to look at for the arc. Okay, first and last name tells me the arc. Well, that's 116 degrees. So then KMN is going to be 116 divided by 2, and that equals 58 degrees for angle KMN. Next, we have a quadrilateral inscribed in a circle. Remember, the rule is if the quadrilateral is inscribed in a circle, that opposite angles are going to be supplementary. So these two angles are supplementary. These two angles are supplementary. Supplementary means add up to be 180. So we're going to go 5x plus 110 equals 180. And the other equation that we're going to do is 2y plus 104 equals 180. So let's solve each then. Subtract 110. 5x equals 70. So x is 14. And over here, subtract 104. 2y is 76. So y is 38. Same thing's going on here for number 19. These two angles are supplementary. These two angles are supplementary. So we have two equations. We're going to go 3x plus 63 is 180. Let's just solve that. We're going to subtract 63 from both sides. 3x is 117. So x is going to be 39. And then for the y's, it's 4y minus 1 plus 65. 4y minus 1 plus 65. And that's going to be equal to 180 as well. So this is 4y plus 64 is 180, which means 4y is 116. And when we divide, y is 29. So x is 39, y is 29. So what you guys have to do then is you have to do page 193, 194, finish up all the problems that I didn't go over. That's 1 to 22, okay? And remember to wash your hands, save a life.